Jody Pollok-Newsom is joining me this morning. Jody, before we get into our program, let's just go through a couple of things here of what's going on with our wheat program here in Michigan.
Oh, we have so many activities, so many events. I'm going to move into a slideshow and kind of give some folks some updates, but it's a really good time to be in wheat. Lots of fun and exciting things are happening. And, you know, it seems kind of, I don't know, it doesn't seem like it's really been long enough, but we are into wrapping up our 10th year. Doesn't seem like we can have been around that long, does it, Terry? It seems like we're the new kids on the block.
We are.
We kind of are. So we're calling it our decade of dedication for Michigan wheat growers. You know, the checkoff was voted in 2011. The board was appointed. We got a group of growers together. There's 9 folks on our board of directors. They started meeting every month to figure out what is the wheat checkoff going to do? Where are we going to be focused? And I think most folks know our mission. We're really just trying to make sure we have a viable, thriving, and growing wheat industry. We definitely work with all the segments of the industry, but where we're really focused is on growers. And how do we do that? Our focus has been from the beginning, growers said, increase yield and quality. So that's really where we've been focused, mainly looking at research. And I talked about research last week, along with the infrastructure and the boots on the ground. The first week I talked about the work we've done for quality. So today I really want to focus on specifically the communications, because if you do the research and you work on the infrastructure, but you don't tell people what you've done, you really haven't done a full job. So just really quickly talking about communications, and I know you guys can't see Dennis, but I can. He has a big smile on his face. We are so excited to announce Michigan Wheat 101. Dennis and I, with the researchers at Michigan State, we started working on this last June. And what we really wanted to do was to have a one-stop shop place where anything, whatever it is I need to know to grow wheat in the state of Michigan, where do I find it? I don't want to bounce around all these websites. I want to go one place. And you know, we've funded research for 10 years. We've spent almost $3.5 million, 150 projects. You can't just put all those reports on a website and go boom, 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 and just list them. So we really brainstormed, how do we get that information back to growers? And the idea was born of Michigan Wheat 101. And it really has been a labor of love. We have been working on this for months, trying to get this just right. So it is done now. It is at the printer. So all of the growers that are on our mailing list that receive the postcard, and I'll show that in a few slides. If you receive that postcard, you are going to get a copy of this 36-page document in your mailbox. If you want to see it right away, you can always go to miwheat.org, that are right down here. That's our website. Up on the side of the website, we have a box that's called What's Hot. That's always a great place to go. That's where all of our new stuff goes first, and then we incorporate it and move it into the website. Michigan Wheat 101 is really meant to be a living, breathing document. We want to make some changes to it. It's up on the website, but we want to get it more searchable. We want to get it so you can go to the table of contents and just click through to the different pieces that you want. But we really wanted to get it up for growers because with the change in weather, we know there's going to be questions right now. The mailed piece will come later this month, probably the middle of the month, but this is out here. This is going to be a document that we keep updating, that we take all of our research reports and feed them in. So you can really look at what's going on in wheat. You can click through and you can get to the information that you need. So we're so excited. You can probably tell we're so excited to finally have this done. But the nights and weekends, and Dennis and I, Christmas weekend and New Year's weekend, we're working on this, trying to get this done and ready, and are so proud that it's done and it's out. Also, I want to make sure I mention our annual report. The annual report will be mailed with Michigan Wheat 101. So Michigan Wheat 101 will carry all the research, and then the annual report will be all the other programming we've done. If you go onto the website, again, in the What's Hot box, you can see it. Also, if you go over and look under information about the program, just click the About tab, you can see every annual report we've done since 2013. So lots of information. I just want growers to know it's out there, because the way the weather is, I think pretty soon you're going to be out working on equipment and getting ready to head into the field and not really paying attention to what's on the website. Also, I just want to mention on our communications is Facebook. Several of you are out there and follow us. Our Facebook is also set up to be able to work with our industry partners, but probably also more of a consumer interest than the website. So we work a lot with Wheat Foods Council, put up different recipes, put up different kinds of flours, just do some basic education, but then we also share updates and information. And as Terry knows, most recently this year, to go Facebook Live with all 6 of these webinars. And Terry was really good in pushing this, because I said, we've never done that before and we don't know how. And he said, you'll be fine. And so far it's worked great. So if you haven't liked us or followed us on Facebook, make sure you give that a look and check out and see what we're doing. Also, we have the e-newsletter. I want to make sure you folks are aware. This comes out every month. We go to about 2,000 readers across the state and in other states. Really easy to sign up. And this is meant to be a short listing of all your topics. And then you just click through to the article. So if you have no interest, you don't have to look at those. But if there's something there you're interested in, you can do a quick click. So this is meant for you to look at in a couple, 3 seconds to decide if you want to look or if you're really not interested. And we have been doing that since 2014. You can find that on our website, all of our past e-newsletters, all the research reports, and all of the past events like today. This will be taped, so you'll be able to see Romulo later over and over. That will go on our website under education, previous events. You can see the webinars, and you can also see every annual meeting and every field day that we've ever done. Those are mainly, you can link through our website, but those are mainly housed on our YouTube channel. And here is Dennis Pennington. And thanks to Dennis and Ricardo Costa, who's down in Extension in Southeast Michigan. They have really worked on developing our videos. We have 93 videos on the Michigan Wheat Program YouTube channel. That's about 48 hours. And that does include all of our past field days and our summer meetings and our webinars. So if you haven't been there, great place to go, find the topic you need, and you can watch it live and then go out to your field and you are set and ready. The big thing we have coming up that I want to make sure that you guys know about is our continuation referendum. As I mentioned, we're 10 years in, and all the checkoff programs in Michigan by law, every 5 years, you go back to a vote if you're established under Public Act 232, which we are. So you can see over to the side, that was the draft, but that's pretty much what the final ballot looks like. We just sent the mailing list Monday to the Michigan Department of Ag and Rural Development. They're preparing your instructions, the ballots, the return envelopes, all of that stuff. And March 10th, that will all be mailed to the growers. When you get that, you need to read those directions. You need to vote popular vote, and you need to vote your production from either 18, 19, or 20. You have to sign it, and it has to be postmarked on or before April 2nd. If any one of those things is not done, they will not count your vote. So what happens? The program continues if more than 50% of production and more than 50% of the popular vote yes. Then we will be continued till 2026. So that's what it takes. That's what we're looking at. This is really our signature postcard. If you get this postcard for all of our events and activities, you are on my mailing list. You will get the Michigan Wheat 101 and you will get a ballot. If you do not get this postcard and it does not look familiar, get a hold of me. I can still get your name and address to the Department of Ag. They're just starting to work on it, but that's how you reach me. That's how you get all of your information about Michigan wheat. So if you have questions, if you want to know what we're doing, watch the next webinars, because every one I talk about something different, or you know how to get a hold of us and how to visit us. So I think with that, probably Terry, that's kind of a quick pull together of the communication side, and most importantly, the reminder about the vote. We want to make sure people get out and vote.
Fantastic, Jody. And we'll come back to you a little bit later on as well, and let you go through again that checkoff process, because yes, it is. It's vitally important.
It is. It is.
Now, let's put the checkoff to work, okay? This is what you call checkoff into practice. I want to introduce, first of all, Dennis Pennington. Dennis, I saw in the picture there where you had your Spartan jersey on in the picture. Yeah. You can wear it. You can wear it proudly this morning, okay?
Yeah, no kidding.
They did win. Mm-hmm. It's been a tough struggle so far for our Spartans. Dennis, we've got a real interesting program, and as I said, the checkoff dollars now are coming to fruition. Folks are going to be able to appreciate some of those checkoff dollars, the results of that this morning.
Yeah. So, and that's one of the things. We've got Dr. Romulo Lollato from Kansas State University here. I'm going to visit about some of the things. He's been involved in a number of research projects on a wide range of different topic areas. He's got some background in talking about yield gap and identifying the yield gaps in wheat, and trying to help farmers figure out ways to address some of those problems and continue to grow great wheat. And he has a really good, strong relationship with his wheat grower association in Kansas as well. So, Romulo, I think you're up, and we're really excited to hear what you have to say this morning.
Very well. Well, thanks, Dennis, for the introduction. Also, I really want to say that I appreciate the opportunity to be here sharing some of the things that we are doing here in Kansas, and especially how we're putting the checkoff into practice, right? What type of research are we doing with the support from wheat growers, and why it is important, right? So let me go ahead and share my screen here. Good. Can you see it there, Dennis?
Looks good. Looks good, Ram.
All righty. So, okay, folks. So today, going to touch base on topic here, checkoff into practice. So really what I try to do is to summarize these last 5 or 6 years that I have been with Kansas State University, and all of the research that we have going on, particularly in high yielding wheat. And I say high yielding, it's important to keep in mind that for our growing conditions, right? It's an environment completely different than the one that you have in Michigan. But today the presentation has 3 main parts here. So first, I have a very quick background on the checkoff program and on the region as well, right? Maybe we're going to spend 3 to 5 minutes here, just giving a little bit background on how the checkoff works, and then how is wheat production in Kansas and in this region here. And then we're going to move on to the actual more applied part of these, and really what we can learn from grower data and from our small plot research that we have been performing here in this last about 5 to 6 years. Okay, so brief background here on the Kansas Wheat Commission. And I do appreciate, Jody, the background that you gave on the Michigan side, right? So this is essentially as well a grower association. It was established back in 1957. Essentially, it's farmer funded. And the way that it works here in Kansas is that for every bushel that is sold in the state, about 2 cents come back to the Kansas Wheat Commission, right? So that's it's not a percentage, it's actually a flat rate, 2 cents per bushel there. And those 2 cents, they are partially used to cover the costs of the commission, salary and structure and energy and whatnot. But a lot of that is invested back in research as well. So the mission of the commission, education, research, and promotion. So how does that look? The 3 main focuses here that the commission have will be plant breeding, right, to improve wheat variety yield, milling, and baking. And now that you see there that I also added here breeding and agronomy. Okay, and this is my edit here, and we're going to look and see why agronomy is as important as it is, especially here in Kansas. Then increasing domestic consumption of wheat-based products and improving international education, utilization of Kansas wheat. And the structure here where the Kansas Wheat Commission is located, it's called Kansas Wheat Innovation Center. You have a picture of it here. It's right here in Manhattan. So it's on the backyard of the university there, which is excellent. It is a $15 million structure that has greenhouses, and there's a lot of research that goes on there, and a very good public-private partnership as well with several industries that have office in this building. So it's an excellent resource for us to have here, and essentially that's how the program works, right? 2 cents per bushel goes back into the commission, and that's used partially for cover research and those other 2 initiatives that they showed last slide. Okay. With that background on the Wheat Commission itself here in Kansas, and having in mind that that's the type of funds that we're going to talk about, it's grower funded research. Let me give you a background of wheat production in this region, right? Very briefly as well, just because it differs so much from Michigan, and we have listeners from up to 4 countries here and 14 states. So I want to make sure that everybody kind of has a good idea of the environment that we're talking about. So in this map here, you have the green area that you see is the wheat area in the southern Great Plains, right? You see there that we have the states of Colorado, Kansas, Oklahoma, and Texas. And together, this region is the largest winter wheat continuous dryland winter wheat production region in the world. And there is a huge variability in climate in this region. If we talk about Kansas per se, right, which is going to be up here in the northern part of the southern Great Plains, we have there about 7.5 million acres planted to hard red winter wheat every year. There's a little bit of hard white as well, but the bulk is hard red winter wheat. About 350 million bushels produced on average. It ranges from 280 to 420, more or less, depending on yield. Now, what's interesting that I want to call your attention here is that there are very strong gradients in rainfall and evapotranspiration as well. So if we look from west to east, right, from the western growing region here all the way to the eastern growing region of wheat, the rainfall in season ranges from 8 all the way to 25. So it's a very large range for in-season precipitation there that we have. Again, this is looking at 30-year average, okay? So 8 inches in the west and increases to 25 in the east. And the reference evaporation or evapotranspiration, so the water demand, it flips around. So we have an inverse gradient there, where it's higher in the west, about 30, 32 inches in season, and lower in the east to about 23 to 25 inches. So there's really a very severe water deficit as we go to the western part of the region. And as we go to the eastern part of the region, we're looking at more of a subhumid type of environment there. And on average, the last 5 years there, we have been at about 10 years, about 48 bushels per acre yield average. So that's the average, right? Our main question here is, okay, how far from our potential are we if we have those 48 bushels per acre average yield there? So in this figure, you see a lot of points, right? Green, blue, yellow, and red points. And each one of those is a weather station that we collected data for 30 years. So we could estimate what's the potential with yield in the last 30 years, right? What has been the potential in the last 30 years in all of those 70 plus weather stations that we have showed in the map there. And if we go ahead and look at this potential, and I'm going to give a few very brief definitions of what we're looking at here. When we look at the potential yield, the blue bar there, we're talking about what will be the maximum yield that's only dictated by environment if everything was irrigated, right? If there's no water deficit here and everything was irrigated. So this is genetics, our current varieties, how far they can push, and the environment as well. On average, in the last 30 years, we would be able to have reached about 115 bushels per acre yield if everything was irrigated and if everything was managed perfectly. Okay, this is not realistic, but it gives us a good benchmark to see how far we are, right? Now, maybe a more relevant benchmark is, if not talking about irrigation now, but just dry land, because we have a lot of dry land with production here. So that gives us the next bar, the yellow one, the water limited potential yield in the region, meaning if the management is optimal, but we're talking about whatever rainfall we have and the water holding capacity of our soils as well. Now, the average of the last 30 years on that entire region, we're looking at about 75 bushels per acre. At the same time, our current yields are about 48, right? And this current yield here, then it's the average farmer yield on the region. Then we have suboptimal management, right? Either it is fertility or diseases or insects, spatial variation, soils, and farmer to farmer variation as well. So the message here is that there is a gap there that we can manage. Now, this gap is not genetics, right? The genetics, the potential is already there. We can reach 115 or more. Some of our trials under irrigated conditions, some years, we reach 150 bushels per acre. So the genetic potential, the varieties are there. The environment brings it down to about 75 because of the severe water deficit that we talked about. And on average, we are 48. So if we look at this potential yield, it's really not relevant because 96% of our production is dry land. So let's ignore that for now. And let's just look at the difference that we have between our actual yield and what farmers could have gotten in the last 30 years if they had managed everything to the perfect conditions there, right? We have a yield gap there of about 27 bushels per acre. Now, some of you are probably wondering, this is not economical, right? If I'm a farmer, I don't want to manage for the highest yield every year because especially in a region as dry as we have in Kansas with such year-to-year variability in the weather. But economically, probably this yield gap of 36%, we could bring it down to about 20%. There's some research showing that 20% is usually economical. So in other words, in the last 30 years, there has been 10 to 12 bushels per acre that the farmers could have capitalized on, and we didn't. Now, that's what we're talking about, the potential to improve yields economically, right? Still maintaining profitability there. We're talking about a gap of 10 to 12 bushels per acre there to bring the yield gap to 20%. Okay, so that's a background of the region. That's kind of the size of the gap that we're talking about economically being able to fulfill. Let's switch gears now and go into our management research that we're doing with the checkoff dollars from the Kansas Wheat Commission and how that's trying to answer some of the practical questions on how do we get there? How do we fulfill this yield gap? Now, before getting into the research, as you all know, right, yield, it's going to be dependent on the number of kernels per head, kernel weight, and heads per acre. So essentially, that's a trifecta there that builds yield. And we have management factors that are going to be yield building factors, right? Like when are you planting the crop? What's your variety selection? How are you managing fertility? And yield protecting factors as well. Disease control, weed control, harvest management, and all these other protecting factors. Now, the biggest challenge that we have with small plot research is that we can only look at a few of these at a time, right? If you're doing a study that we're looking at genetics, so variety and fertility, very, very rapidly you can get to a huge experiment. And that's really not feasible, right? For you to put that experiment in several locations and try to really understand what's going on. You can only explore a few management factors at a time. So with that in mind, we kind of started a little bit of a different type of research. That's the one that I'm going to focus on first, that gives us a chance to look at several of these factors together. And then we're going to go into more specific research, looking at specific each one of these individually. So for us to be able to look at more of one at a time, we went ahead and tried to learn from grower data. So what are growers doing? What are our growers doing, right? And how are those practices adopted in commercial fields related to yield achieved in commercial fields as well? That brings us to the second part of the presentation. So here, let's first, before getting into the average wheat grower in Kansas, let's look at the top, right? Let's look at the guys who are yielding the most around the state. And to do that, we look back into the Kansas wheat yield contest. Okay, so we're calling them the winners here. What have the winners done, right? So we're looking at the data from the yield contest in Kansas that has been conducted for several years. Each one of these yellow points that you see, it's a field that was entered in the Kansas wheat yield contest over those 7 or 8 years when the yield contest was performed in the state. We're going to look at each one of these points. Actually, they reported the yield and the management practices that were adopted in that field leading to that yield, right? So that's why we're going to try to take a look here and see what we can learn from these very high yielding growers for our conditions, right? And what were they doing as far as management goes in their field. So first, let's take a look at the yield levels that we have here, right? We have the harvest year, the number of fields entered in the contest in those years, and the average yield. So you see that the average here kind of ranges from 67, some years all the way to 90 plus. but on average here, we'll be pretty close to that 75 bushel per acre that we estimated being the potential. So that tells us that these guys are pretty close to their potential. But we had yields ranging from 32 bushels per acre all the way to 120 bushels per acre entered in this contest, when the average statewide was ranging here from 35 to 56. So you see a very, very big difference there between what the winners were doing there versus the state level. So let's get these growers that were entering in the yield contest already, and let's split them in two groups, right? Let's look at the highest yielding groups, highest yielding fields versus the lowest yielding fields here. So if we do that, we see here that the yields, so we're looking at grain yield here, and then in the light purple bar, you have the low yielding groups. So we have 30 fields there that were the lowest yielding among all of those entered. And we have 30 fields that were the highest yielding groups among all of those entered as well. So you see that the yield levels range there from 60 bushel on the low yielding one to about 195 bushels in the high yielding one. So we have a 35 bushel per acre difference between those groups. Now we can start asking ourselves, how has the management differed in the high yielding group versus the low yielding group? How has the adoption of different practices differed between the high yielding group and the low yielding group? So for example, if we look at seeding rate, right, that's the first thing that we're looking at here. We did have a significant difference of 200,000 seeds per acre there. Interestingly, that the low yielding group were actually using a higher seeding rate, about 1.2 million seeds per acre, compared to 1 million seeds per acre in the high yielding group. So that tells us, I mean, we can start seeing some of the difference in management between those high yielding fields and the low yielding fields. Same thing if you look, for example, at phosphorus fertilizer, right? We have a frequency, so how many of those fields, percent of those fields actually used phosphate fertilizer. And we had a difference of about 20%, where about 50% of the fields in that high yielding group was using phosphate fertilizer, usually applied in furrow with the seed at sowing, as compared to only about 30-35% of the fields in the low yielding group using phosphate fertilizer. Same thing, we can look at adoption of foliar fungicide, for example. Now it's interesting that you see that the majority of these fields used foliar fungicide, right? Even in the low yielding group, but still we had a difference of 20% there of adoption, meaning that the high yielding fields, they were more frequently adopting foliar fungicides than the low yielding fields. Going a little bit more into the interaction of management and genetics here, if we break down on these commercial fields, the adoption of foliar fungicide and grain yield per variety resistance to the major diseases, right? So that's what we have here. On these left bars, we have leaf rust, resistant varieties versus susceptible varieties. On the right-hand side, we have stripe rust, either resistant varieties or susceptible varieties. And yellow, no fungicide, and in blue, we have fungicide. So it's interesting to see that the resistant varieties, either for leaf or stripe rust, they're not really gaining. I mean, we didn't really see much difference in yield there between fields that got fungicide or fields that did not. But in the susceptible varieties, we did have quite a bit of difference there between fields that got foliar fungicide and fields that did not, up to 20 bushels per acre difference there. Now, keep in mind, folks, whenever we're talking about grower data, we cannot really say that fungicide increased yields, right? We're just trying to find associations here. Yes, these fields, they were yielding more than the ones that did not apply fungicide. So that's one disadvantage of using grower data like this, is that we can't really say have cause and effect relationship. We're more looking and trying to find patterns of more frequently adoption of management and things along these lines. Okay, so this is an example for the highest yielding participating in the Kansas wheat yield contest. Now, after we saw that data and we were seeing, we can learn a lot from grower data, we went back to the Wheat Commission and said, well, let's expand this, right? Let's try and really look at this across the majority of the state in a lot more fields, many more fields, and not necessarily just looking at the highest yielding guys. Let's look at the average grower in Kansas, trying to represent from the lowest to the highest, but representing the average there. And let's see what we can learn from that. So that brings me to the second project that we're going to discuss here, which is when we expanded that survey, again, funded by the Kansas Wheat Commission, to try and see what we could learn from growers in Kansas, from average growers in the state. So we see there the very same map with the wheat area shown in green, and each one of those yellow points are a field that we were able to collect management data from. Again, all the management adopted in that field, all the way to the grain yield. And we were actually close to 700 commercial fields that we were able to get data from for 3 years, 3 growing seasons there in the state. But what kind of data are we collecting? And then I'm going to show here the type of survey that we were running. Here you see what, like, honestly, we were sitting down with growers and trying to ask them for, okay, well, this field here, field 1, tell me exactly everything that you did there from before planting all the way to harvest. Field 2, field 3. So these are field specific data. Okay. So here's an example, right? What was the 2 year before? What was the previous crop? What's the immediate previous crop in that field? What was the planting date, variety, seeding rate, row spacing, all the way to, so this, each column here is a different field. So these growers providing 4 different fields to us. We turned the survey to the other side there. We had fertility management, fungicide management, all the way to grain yield. And if they had protein, we were collecting protein as well. So that gives you an idea of, for those 700 fields that we were collecting data from, the data that we had, right? All the management data from variety selection all the way to yield. And out of those 700 fields, what did our yields look like, right? And that's what we're looking at here. We have our grain yield in the bottom. You see that it ranges from about 5 bushels per acre all the way to 106 bushels per acre among those 700 fields there. And here we have how many times that yield level happened, right? So for example, here yield level is about 20 bushels per acre. We had about 15 fields reporting that yield level. If you look at the grain yield, about 50 to 60 bushel per acre there, we had 60 to 70 fields reporting that yield range. So this just gives you an idea of the distribution of the data, how many fields were at each yield level. So the average that we were, about 57 bushels per acre, again, ranging from 5 all the way to 106. And whenever we go into Kansas again and try to understand, so a couple of things that we can do with this data. First, how are our growers managing their fields, right? What's our typical level of adoption in each one of those commercial fields? And then 2, what are the differences between the highest yielding fields and the lowest yielding fields in terms of management adoption? So if you look at the state now, one of the things that we talked about was the weather differences that we had around the state. So we had to group these fields in regions that were a little bit more similar, right? So we were able to really understand management-wise what was happening there. Otherwise, we have too much variability from the weather and it really confounds things. We divided the state in 3 regions there. We have the West in purple here, which again, it's a dry region, less than 24 inches of annual rainfall, and a cool region as well. North Central, which is 24 to 35 inches of annual rainfall. So this is not in season, it's annual, and cool region as well. And South Central, where we have a higher rainfall as well and a warmer region. So we have a dry and cool, moist and cool up north, and moist and hot down south. So these are essentially the 3 regions that we divided the state in. So we can actually start learning what's happening in growers' fields and how that associates with yield. So the first thing that we can do, again, is have a snapshot of how our growers are managing their fields on average, right? And that's what, just our curiosity, I'm showing this to you here. What's the average sowing date there and day of the year? What's the average seeding rate in each one of those regions, North Central, South Central, and West? Percent no-till adoption, percent phosphorus adopted in furrow. Fungicides, right? You see the flag leaf fungicides here, just about half of the fields we're using in the central part of the state, and about 40% of the fields we're using in western Kansas, previous crop, and so on. So we really have an idea of how our growers are managing. And then we can also see, okay, well, if only half of them are using fungicides, is there really room for us to improve there, right? Because, I mean, we have half of the growers using it, meaning that in the other half, we could still improve yields simply by a fungicide application, for example. Now, the second thing that we can do, maybe even more interesting than this snapshot of their practices, is how are these practices associated with yields around the state? So let's give the example of sowing date, right? When are our growers planting? And if you look at the western region, the dry region and very cool region that I showed before, again, this is the distribution of the sowing date in commercial fields, right? We have here on average, we were planting on October 1st. So this is in days after September 1st. So day 20 here will be September 20th. Day 40th will be October 10th. So we have a good distribution there of fields being planted from the 14th of September all the way to the 26th of October. Now, the question here becomes, how are the yields associated with these different planting dates, right? And this is what we're going to show next. This is what we have here. So it's interesting to notice that we have, again, in the bottom, the sowing date in days after September 1st, and we have grain yield in our left-hand side. Now, it's interesting to see if growers are shooting for 20 to maybe 60 bushels per acre there, not much effect. I mean, it didn't really matter if they were planting September 14th or October 10th, right? I mean, everything was about the same yield level. Now, we're interested in knowing the yield potential. How far can these growers push yield, right? And how does sowing date affect that yield potential? And that's what this line is showing you. We're just getting the highest yielding fields, and we're feeding there a curve to tell us what can we learn from the effects of sowing date on the yield potential. And in this example for Western Kansas, we see that the peak was September 28th, meaning that if I wanted to maximize, to make sure that my yield potential is the greatest, I needed to plant around that September 28th timeframe in that region. I also mentioned that this is a very cool region, right? So it's interesting to notice that if they're going after October 10th, there's a very steep decrease in the yield potential. We're losing about 3.5 bushels per acre per day for every day that we're delaying sowing there. We cannot reach our potential in about 3.5 bushels per acre per day. So a very steep decrease there. If we look now at a completely different region, just to give an example of how this data is valuable there to our wheat growers, we look at South Central Kansas, which is a much warmer environment with more moisture as well, right? We have that very same graph here that we see that the sowing dates actually they ranged from that September 20th, more or less time frame, all the way to early November, right? So we have fields planted in November because it's a warmer environment, they can plant later. So one thing here, the peak is later. The peak is about 15 to 20 days later, meaning that they don't need to be as early in their fields, and they still can reach their yield potential. But the environment is much more forgiving as well. It's a warmer environment, so in the beginning here, they might be losing a bushel per acre per day, but it's not until November 1st that they really start getting into a region where they're losing like about 2 to 3 bushels per acre per day in the yield potential. So you see how valuable this is, right, for our wheat growers. They can know, I mean, and many times they cannot plant at the optimum because of crop rotations. They have a summer crop, for example, they need to wait for harvest, but then they can manage knowing that their yield potential is going to be decreased based on their planting date. So, and for those who can actually be on the optimum time, they actually know what is the optimum time based on commercial fields in the region. Now, because planting date had such an important effect here, I want to just go a little bit more in depth into a different project that we did to really try to fine tune and nail down what our optimum sowing dates were for the region. And this was a collaborative project here with Oklahoma State University and Colorado State University as well. So essentially, we went back and collected variety trial data for 20 years, right? So what you see here, each one of these little white dots is a location in these 3 states where variety performance trials were conducted in the last 20 years. So to give, and the size of that circle is how many observations we have. So just to give you briefly here, we have about 100,000 yield observations that we're using to try and define the optimum planting date for this region. So essentially what we did is we plotted the planting dates of all of those 100,000 observations against grain yield, and we did that curve again to try and figure out what was the peak and how much we're losing if we're advancing sowing date or delaying, right? Then you see here that we have 11 different subregions based again on temperature and precipitation, just so we have more homogeneous regions and we can have regional specific sowing date determination. So I'm going to show you a couple of examples that we were talking about before. So again, we're going to show this Northwest Kansas, Northeast Colorado, cold and dry region. And we're also going to show this South Central Kansas, North Central Oklahoma. That is a much warmer and more moist region as well. That's what we have here, right? On the left-hand side, you have the dry and cool Colorado and Northwest Kansas. And you see that peak is much earlier, right? About day 265 of the year there, and a much more steep yield loss for either side, if we go early or late. And for South Central Kansas into North Central Oklahoma, a much wider sowing date from day 245 all the way to sometime in mid-November there, and not nearly as steep. again, meaning that the environment there is much more forgiving. We have our peak later, about day 285, so about 20 days later, very, very agreeing with the grower data that we collected before, and much less steep yield loss to both sides as well. So just to summarize this in a graph, this is kind of what it looks like. Remember that here before with grower data, we had found September 28th, so very close results to September 25th there from variety trial data. Same thing here, we had found October 14th, and now we're looking at October 13th as the optimum planting date. So this is a couple of different approaches that we went about finding our optimum planting date for different parts of the state, either using grower reported data or using long-term variety trial data. Okay, now let's go back to that grower data and see what else we can learn from those commercial fields, those 700 commercial fields that we have talked about, funded by the Kansas Wheat Commission there. And let's do the same comparison that we had with low yielding fields versus high yielding fields. And I'm just selecting one region here, just the North Central region, just to show as an example. But again, if we're comparing the 20% lowest yielding fields in the light purple versus the 20% highest yielding fields in the dark purple here and their sowing date, there was a significant difference there, only 3 days, but it was significant that the highest yielding fields, they were planted a little bit earlier, right? They were planted a little bit earlier than those lower yielding fields. If you look at seeding rate, we kind of have the same idea here that we had in the Kansas Wheat Yield Contest data, in that the highest yielding fields, they were being planted at slightly lighter seeding rates, and this is in pounds per acre, as compared to the lower yielding fields. So very interesting, we can start learning from comparisons among those management adopted in commercial fields around Kansas and how that's differing from the highest yielding fields versus the lowest yielding fields. Look at nitrogen rate, very consistently in central Kansas that the highest yielding fields were adopting higher nitrogen rates than the lowest yielding fields, in about 30 pounds of units of nitrogen per acre there, higher. Fodder fungicide, again, same thing. The highest yielding fields were much more frequently adopting fodder fungicides as compared to the lower yielding fields, about the 36 versus 75% adoption among those fields there. And this was consistent at the 3 regions that we looked at. So folks, so far, remember that we have all those yield building and yield protecting factors, right? And it's very hard to evaluate all of them in replicated research studies because the research would just be huge, right? But using farmer data like this, it gives us a chance to at least look at several of those management factors and how they are associated with yields. That's what we have shown you this far. We're going to switch gears here, and we're going to go into some of the small plot research now, right? We found all of these from the grower data that we were getting reports from commercial fields in Kansas, either the highest yielding fields on the Wheat Yield Contest, or this last example here with more commercial fields around the region. And we were able to find a few things, right? Fungicide, for example, was a very important factor there. Nitrogen management as well, right? The adoption was very different between the low and the highest yielding fields. So now the question becomes, okay, we see that there are these differences. Let's go ahead and put this small plot research now focused on these specific problems that we found from commercial fields. And let's try to see on the long term, how often producers are going to at least break even in their investment from going with a more intensified management. And that's what we're going to touch base now, right? What is some of this other research that we have going on high yielding wheat? And it's going to be more focused now on small plot research, replicated research around the state. The first one that we're going to touch base on is, again, remember that nitrogen and fungicide were important factors in our commercial field evaluation. So let's look at the interaction between varieties, right? We have over 60 varieties that growers can select from here in this part of the state, and management. How are these different varieties responding to a more intensified wheat management? And this project that I'm going to share with you now, it has been conducted in over 20 locations during a 6-year period there, right? So we have quite a bit of data on these now, close to 3,000 observations of yield on how different varieties are responding to management. So we have anywhere, depending on the trial, anywhere from 20 to up to 50 varieties. And we're looking at 2 different management strategies. either standard management there, where we're shooting for a yield goal of about 60 bushel per acre. That's how much nitrogen we're putting out there. And we're controlling weeds and insects and whatnot, but we're not applying fungicide, right? Having our nitrogen rate sufficient for that about 60 bushel per acre yield goal, considering how much nitrogen there is in the profile. And this was applied about fixed tree, so that was late February to early March, depending on the location there. And we're comparing all of those varieties versus a more intensive management, where again, we're going back with another shot of nitrogen. So we're putting another 40 units of nitrogen at fix 5, so a little bit later. So we have again nitrogen rate that is higher, and we are supposed to have as well perhaps a more efficient use of the nitrogen because we're splitting the application in two. And we're going with a couple of fungicide applications, one at jointing and one at flag leaf. So really making sure that the full protection, what are we gaining from that? This is one example of how it looks like. It's a photo from Brian Arnall there in Oklahoma using a drone. So what you see here, we have, so this is an aerial photo. We see 4 blocks, right? Block 1, block 2, block 3, and block 4. Each one of these little rectangles here is a different variety that we are evaluating. So in this case, we're probably looking at 40 or 50 varieties. And the block in the lower part here is our standard management versus the block in the upper part with our intensive management here. So a few things that we can see just based on the color of this figure here is that the upper part of our intensive management, again, more nitrogen and a couple of fungicide applications, have a much better green leaf area, right? This photo being taken sometime mid-grain field, mid to late grain field there. Much better green leaf area, right, as compared to the lower one. So some of these plots are really toasted here with not much leaf area left, especially those more susceptible varieties. But we also see some lodging, right? Some of these varieties here, where it's a little bit more shiny, they're kind of showing lodging as well. So, I mean, we need to be careful with that. It's not only going there and putting more nitrogen out. We need to be mindful when managing our nitrogen rates there. But taking a little bit closer look here, right? This is an example of variety that have pretty good standability in our standard management versus our intensive management. And you see just how many more heads we have out there, right? Heads per foot. Many more heads per foot out there, much more biomass as well, just overall a much higher yield potential crop as compared to our standard management. And some of the disease conditions that we have during this study are shown here as well. You see that the stripe rust was, in some of these years, were extremely high. And so you see no leaf area left here, mid-grain field. So that's why one of the biggest reasons of our yield gain from the fungicides there as well is just this stripe rust. In fact, if we take a look at and quantify how much green area we have in a susceptible variety during mid-grain field, here's a susceptible variety with our intensive management that is receiving fungicide. And here we have a photo quantifying the green leaf area. We have about 99% of green leaf area. If we look at the same variety, neighboring plot without fungicide, we only have about 56% of green leaf area. So we're looking at 40% green leaf area less, right? And this reflects in light interception. So we have 40% less light interception there. Water use as well, right? The full canopy of 99% green canopy cover is using all the water through transpiration, whereas in the canopy that only has 56% canopy cover, we for sure have a lot more evaporation, losing water from the soil as well. Okay, so let's look at the gap. Let's look at the difference for the same variety, right? The difference between those two management across all of these site years that we have so far. This is what we're looking at here. What's the size of the gap? So how many bushels per acre are we gaining? So this is just the difference between the standard versus the intensive management. And this is how many times that difference occurred, right? So here we're looking at 17 site years. So it's not the full data set, but 17 of them, over 2,000 comparisons, okay, of that you get with versus without the nitrogen and fungicide. So the average was 12 bushels per acre. That was the average, but you can see here that it ranges from negative. So sometimes we were losing some yield or going with that high management. This probably some seasons that were very dry and we're having more biomass because of the management. That's not helpful when you have a very dry environment. The crop is going to use that water earlier and so can result in yield loss. But our yield gain, I mean, it goes all the way to close to 70 bushels per acre yield gain on an extremely susceptible variety in conditions of extremely high stripe rust or leaf rust incidence there. But on average, we had about 12 bushels per acre yield gain. Look back, remember what was the size of the economical yield gap that we talked about? 10 to 12, right? So, I mean, this is exactly what our research is showing. Just with some extra nitrogen in a fungicide there, we can fill that economical gap, and producers will be more, will have a higher probability of making profit there at a higher yield level as well. Now, this is across all the varieties. If we break this down by variety, now we had too many varieties, so if we break it down by variety, susceptibility to the major diseases, right? That's what we're looking at here. So that's the size of the yield gap. Again, it goes from about a negative few bushels per acre there, all the way to close to that 70 bushels per acre. This is the probability, 100% probability of getting that response, right? And 0% probability of getting that response here. And in green, we have our resistant varieties, in yellow, our intermediate varieties, and in red, our susceptible varieties to stripe rust in this case. So you see here that for the resistant varieties, our yield gap is just 5. I mean, we could give all that management, more nitrogen, fungicide, and whatnot. We're only gaining 5 bushels per acre. So not really economical, right? If we're spending all that money with that extra management. Now for the susceptible ones, we're gaining up to 15 bushels per acre on average. So that's the 50% probability, right? That's on half of the times you can expect very consistently getting those 15 bushels per acre yield gain. So you see that there is an interaction between the management and the genotype piece here that we're trying to fulfill with this research funded again by the Kansas Wheat Commission. Some of these cases, we went a little bit ahead and trying to understand physiologically what's going on, why are we gaining this yield, right? And so very briefly, I'm not going to spend much time here, but very briefly, what we have here in these 4 panels, in the left-hand side, we always have the yield. And in the bottom, we're trying to look at the yield component that is being changed by our management. In red, you have the standard management, and in blue, you have the intensive management of these trials. And we see here that yield was quite well related to above ground biomass. So for the most part, increasing biomass through management was increasing yield as well. Not related at all with harvest index. That was interesting. I mean, across genotypes, across locations, and across management, there was really not much relationship of the harvest index with yield there. So biomass was actually a biggest driver of yield as compared to harvest index. Same thing if we look at grain number and grain weight, right? So if you look at grain number here, essentially how many grains you have in a square foot, right? In this case, we're looking at a meter square here, but I mean, the important message here is just the relationship. Grain yield, very highly related to grain number. So whatever practice we can make to increase grain number, whether through the fertility, increasing the number of heads out there, or fungicide, making sure that those late emergent tillers are going to still produce a head. But grain weight was not related. So across locations, necessarily increasing grain weight was not necessarily related to increases in grain yield. So again, biomass and grain number being much more related to grain yield than harvest index and grain weight. Okay, folks, so far we have dealt with a more intensive package looking at both nitrogen and fungicide. The disadvantage there is that then we cannot nail down how much of it's coming from nitrogen, how much of it's coming from fungicide. We started a set of trials more recently now. We just have 1 year of data, so I'm not going to spend much time on it, but where we have varieties by fungicide management and varieties by nitrogen management. And very briefly here, right, if we go into that fungicide by variety experiment, essentially we're looking at 14 different varieties and 4 fungicide managements, either a no fungicide or 1 fungicide adjointing, 1 fungicide adheading, or both. So we're trying to nail down what's the value of that early fungicide. The late one, we know that it's pretty consistent, but what's the value of that early one and of the dual fungicide as well. Across a range of, across 14 varieties, they have a range of resistance to different diseases. So far, we have had 9 locations. 5 of them were in the first season that I'm going to share today, and 4 are still planted this year. But again, that very same response. If we have a resistant variety, like this LCS Chrome, very resistant to stripe rust and some other major diseases. With the fungicide, we had about 85% green canopy cover. Without fungicide, pretty close, about 78 green canopy cover. If you look at a very susceptible variety now, with a dual fungicide, we had about 80% green cover. no fungicide, about 66% green cover. So a lot of leaf area loss because of the absence of fungicide on these susceptible varieties. And just, I mean, summarizing these the 5 locations that we had last year on this trial, I'm not going to go into detail on variety name because it probably doesn't matter for the audience here today. But what matters is that we have here the average across those 5 locations of each variety with no fungicide, and then how much yield were we differing from a fungicide early on at fix 6, fungicide later on at fix 10, or that dual fungicide combination. And what matters here is that that early season fungicide on average was only gaining about 1.8 bushels per acre, but in some of these varieties they were gaining up to 4 bushels per acre. So it can be relevant depending on the environment. The gain from the late season application was higher, right? It averaged about 3.3 bushels per acre, but it was as high as 7.5 depending on susceptibility of these varieties. And then the dual fungicide, you know, it was on average getting us about 4.3 bushels per acre, and it was up to 10 bushels per acre. So remember, when we were doing both fertility and fungicide together, our gains was on average 12. Here from the fungicide only, we're gaining about 4. So that gives us an idea how much of the limitation was coming from fungicide, how much was coming from nitrogen, although this depends season by season. And another thing that I always call attention to producers here is that some of these varieties, they were yielding quite well in the no fungicide, but they didn't gain much, meaning that their potential is already there and they have a pretty good resistance. So perhaps with the right variety selection, we might get by in our conditions without a fungicide application. If we very briefly review the same trial now, but looking at the nitrogen side of things, right? Again, those same 14 varieties, 4 nitrogen rates, either 0, 40, 80, or 120 units of nitrogen per acre, 8 locations across 2 seasons. Now, I want to call your attention, I don't know, probably in Michigan this differs quite a bit, but our initial soil nitrate in the profile among these locations ranges from as low as 26 to as high as 172 pounds of nitrogen per acre. So you can really expect the difference in response based on how much nitrogen we had in the profile already. And this highlights the need for soil testing, especially for nitrogen in our conditions. But if we just visually take a look at these varieties under the 0 nitrogen conditions here versus the 120 units of nitrogen per acre in one of our locations here, this location is one of those that had the lower nitrate in the profile at sowing. We can really see the difference in biomass there, the difference in heads per acre. Remember, being those 2 being the biggest drivers of yield in the region. Just see the difference in biomass. You can easily roll this crop versus you cannot roll this crop here, and that also goes about with the number of heads that we have out there. Now the question that we have is, do the different varieties, do they respond differently in terms of nitrogen, right? And very briefly, just going to show you a couple of examples here. We have the total nitrogen available, and this is considering what we applied plus what was available in the soil at time of at sowing, and our grain yield. And this is in low yielding environments. Okay, we have the 2 most compressing varieties across the data set here. A couple of important things that we look at in the low yield environment here, you know, their breakpoint, one of them was 102 units of nitrogen per acre needed for about a maximum yield of 47 bushels per acre, versus the other one with slightly greater there, 109 units of nitrogen per acre needed for 52 bushels per acre. So not much difference between varieties in terms of response to nitrogen in low yielding environments. If we look at the high yielding environments, then we actually have a much larger difference there, in that the lowest yielding variety was maximizing yields at a total of nitrogen available 206 units of N per acre, maximizing at about 64, whereas the other one was the model was giving us 230 units per acre there to maximize 84. But honestly, if we look at these, it had already maximized early on, right? I mean, so the model is giving us something there, but if we really look at the data, it had maximized early on there. So what this is telling us is that they're maximizing yields at about the same yield level. So what we really need to study now is, okay, they simply have different nitrogen use efficiencies, where one variety uses nitrogen much more efficiently than other, or is that high yielding one lacking on something like protein? For us, hard red wheat country, protein is very important, right? Probably different for the soft wheat country there, but for us, we need 12% protein. That's what we're shooting for. So if this variety is yielding quite well, but it's resulting in 8 or 9% protein, well, might not be of interest. So really, we're dissecting this data a little bit further, right? We're collect a lot of biomass on these. We're looking at nitrogen uptake, and we're going to look at protein as well. So really trying to understand what is going on with these varieties and why are they different in their response to nitrogen. Well, folks, I'm going to switch gears here. We have talked about nitrogen quite a bit and sulfur and fungicide quite a bit as well. But I want to finalize the presentation touching on a different topic that has been a growing concern as well, and it is sulfur. Okay, so more and more we're seeing sulfur deficiency around our growing conditions here in Kansas. And the reason we're seeing more sulfur deficiency, if we look historically, right, that's what the graph that you have here. In purple, you have sulfur deposition in the rainfall. How much is coming down to the rainfall? And this is measured in undisturbed conditions here in Kansas. So you see that it went down from about 5 pounds of sulfur per acre average to less than 2, close to 1 pounds of sulfur per acre average deposition in the rainfall, right? And that's because of the Clean Air Act back in the 80s there that really reduced the pollution going up to the atmosphere. It consequently reduced the amount of sulfur being put down in the rainfall. But if we look at the sulfur removal in the harvested wheat, which is the yellow line here, you see that it either became stable or increased. So really, in the balance, we have been mining the amount of sulfur that we had in the soil since about the early 2000s, right? There's been a deficit there that it has only been increasing. And so with that in mind, right, we have less sulfur coming down from rainfall in the atmosphere, and we're taking the same amount or more. This is only considering wheat. We should also think about other crops, right? More and more, we're seeing sulfur deficiency like this, especially early in spring. You can see here, the most of this field is kind of turning a pretty light green there. In the sulfur deficiency, we tend to see them in the upper leaves as compared to a nitrogen deficiency that occurs in the lower leaves. That's kind of how we differentiate them. And because it happens on the upper leaves, it tends to be almost like a brighter type of deficiency than the nitrogen. So this is not severe in this field, but definitely probably enough for some sulfur limitation there. But with that, the Kansas Wheat Commission funded a different project here where we're looking at the interaction of nitrogen, sulfur, and variety. Right, so we went now for 3 years with this trial was actually put in a total of 9 locations so far. We're looking at 3 nitrogen rates, either 50, 100, or 150% of our need for a 60 bushel per acre yield goal. So we soil test at planting, we see how much we have available, and then we adjust our nitrogen rate for the 100% is a 60 bushel per acre yield goal, half of that, 1.5 times that. That's being applied as UAN in the spring. We have 4 sulfur rates, 0, 10, 20, or 40 pounds of sulfur per acre applied as ATS. And all application times are early spring. We have 3 varieties differing in nitrogen use efficiency. It's been conducted for 3 years already in several locations. And these locations, they give us a range of soil textures and organic matter. So let's look at one of these locations with very low organic matter and more on a sandier side. We have these 2 plots here. The left-hand side really has 0 units of sulfur applied. The right-hand side has 20 units of sulfur applied. The very same nitrogen rate. So look at the difference that we have simply by putting out the only difference between these plots, same variety, same nitrogen rate. The only difference is 20 units of sulfur per acre out there. So in sulfur deficient conditions, this is the magnitude of the response that we can have just visually. Look at the biomass, that we have in different canopy cover between these 2 plots as well. Let's look at the same 2 plots later in the season, right? That we have here on the left-hand side, much less biomass, much less heads per feet out there as compared to our right-hand side. Again, the only difference between these 2 pictures being 20 units of sulfur per acre. So let's go now and look at the yield levels, right? In this location where sulfur was extremely limited, right? So again, keeping in mind, it's a low organic matter, sandier soil. What we're looking at here, folks, in the bottom, we have the nitrogen rate for our yield goal, right? It's 50%, 100%, and 150% for that yield goal of 60 bushel per acre. And we have our grain yield on the left-hand side. The 4 lines that we have in black, we have the 0 sulfur down here. In red, we have the the 10 pounds of sulfur, and then in blue and green, we have the 20 or 40 pounds of sulfur. Let's understand what is going on here. First, let's look at the 0 sulfur per acre rate. So first, what we see here is that yields were much lower. Yields were all in that 40 bushel per acre range, right? That's the first thing that we see, much lower than the other treatments. Even though we're putting enough nitrogen for 60 bushel per acre, we never increased to that level. The other thing that we see is that we don't see a response to nitrogen. We can put as much nitrogen as we want out there, 150%, and yields were about the same, right? They were in that 40 bushel per acre range, no difference. So lower yields, no effect of nitrogen. So we see the interaction with the two nutrients there. Now we look at the red line, right? When we're simply providing 10 units of sulfur out there, first thing that we see is at our low nitrogen rate, the yields really go up already. So sulfur is not limiting at those conditions anymore. And we also see a response to nitrogen, increasing nitrogen, increased grain yield. But then it kind of plateaued, kind of leveled out, right? Because probably 10 units of sulfur were not enough for it to continue going up. So it kind of plateaued at that level. Whereas with more units of sulfur, we just had a linear response to nitrogen. More nitrogen we're putting out, the crop was able to respond because we were giving sulfur, the crop was able to respond to that nitrogen rate. So this is with ATS. If we look at urea ammonium sulfate in a different study with sandy soil, organic matter, same thing. Here, the 0 sulfur, again, different study, but just using the solid instead of liquid. Sulfur source, same thing. Yields were leveled without any sulfur application. Once we had sulfur out, the yields came up at the low nitrogen rate, and there was a response to nitrogen as well. Now, folks, if we go to more of a silty loam or silty clay loam soil with average to high organic matter, 2.53%, then the effect of sulfur was not there anymore, right? Whatever the crop needed, we were able well, the organic matter in the soil was able to release that sulfur enough for those yield levels that we were shooting for. So again, here, as we were increasing nitrogen rate in these average to high organic matter sites that we had, we are also improving grain yield, kind of irrespective of sulfur there across these locations. This kind of summarizes all these locations that we had this nitrogen by sulfur experiment. Really, the biggest potential for response being those sandier soils with low organic matter there. So, folks, this is getting to the end of my presentation here. In summary, right, what I'd like to share there, and you have my contact information on the screen there, either my email. Make sure that you follow me on social media as well, Twitter or Facebook there. But really, in summary, we showed that there was an important yield gap in the region that could be fulfilled through agronomy. Our varieties already had the potential. I mean, some of those trials, our varieties are getting 150 bushels per acre. So there is the potential. The varieties already have the potential to reach that. So through agronomy, how can we get there? And the Kansas Wheat Commission saw that as an opportunity to improve management recommendations, to improve our average grain yields in the state as well, and really invested back in agronomic research, and in that research that is in the genotype by management type by environment. We need to have the environment there, but it's always that interaction of varieties with the management, right? We're always trying to tackle that from a G by M perspective. And so we showed you data coming from highest yielding growers in the state. We show data coming from commercial fields, average yielding fields in the state as well, that we were able to get several thoughts on different management factors, both those yield protecting factors and those yield yielding factors as well, right? Because that type of research allows us to show, to investigate many independent variables, many management variables at one time. And then we also showed that we identified the major problems, and then we went back with small plot research that we can be more focused now, just focus on a few of those at a time, evaluating the wheat variety response to nitrogen, to fungicide, and to sulfur as well. So thank you, folks, for sticking around. And again, I really appreciate Dennis the invitation to be here and participate, share some of the things that we are doing here in Kansas with the support of the Kansas Wheat Commission. And I would like to take any questions if there are any.
Yeah, Dennis, I see we do have some questions out there.
Yeah, we sure do. So yeah, nice job, Romulo. We do have a few questions, so if you're all right, I'll read questions to you, and you can respond if you like.
Definitely.
Okay. First question, on seeding rate study, are you factoring in a double crop wheat after soybeans or corn?
Yeah, that's a very good question there. So I didn't show much data from our seeding rate studies, but we have, similar to what I showed for fungicide and nitrogen, we also have variety by seeding rate study. And we run those at a wide range of conditions. We run those from fallow ground after an 11-month fallow that it's planted at the optimal time, all the way to a crop that is planted right after soybeans. So double crop wheat after soybeans there that is planted late into a soil profile that is much drier, honestly, right? And there are huge differences in response there. Usually, if we're planting at the optimal time, we honestly, if we have enough fertility out there and the fall happens to be an open fall with moisture and with temperature as well, we haven't seen much response to seeding rate. I mean, some of our trials were going as low as 200,000. Oh, sorry, yeah, 200,000 seeds per acre, all the way to 2 million seeds per acre. So the range is really wide there. And if the fall conditions are right and the optimum planting date is there, many times we're maximizing our yields at about 500 to 600 seeds per acre there. We see no response beyond that. And so those conditions are accounted for. Now, we go into those other trials that we're looking at after soybeans, the very same trial, but it's being conducted planted late after soybeans to represent those conditions. Many times we see yield increases up to about 1.4, 1.5 million seeds per acre. So definitely the sowing date and the cropping system needs to be taken into account if we're looking at seeding rate studies. The data that I showed here from commercial fields, it's in there, you know, but we didn't break that down by cropping system. So it's in there. So we showed that the highest yielding fields were planting earlier at a lower seeding rate. So that probably also means that the lowest yielding fields, they were actually being planted late at a higher seeding rate, meaning that growers are compensating for that late planting, right? So yeah, great question, in our replicated studies, we definitely take care of that. In the farmer data, it's a little bit more confusing, right? Because each of those fields, they have a range of management practices that they have adopted. Yeah. But yeah, we need to take care of that.
Yeah. So, and actually, Romulo, that kind of leads me into the next question. And this was a question that was typed in kind of early on when you were sharing the grower data. The question is, does the grower data indicate a higher seeding rate in areas of higher rainfall? I know you had those charts that showed, you know, from west to east, the gradient of rainfall. What was your response that you saw in seeding rates?
Definitely. So there was definitely a gradient there. So in Western Kansas, the average seeding rate, and again, most producers reported in pounds of seed per acre. So we're gonna talk up in that unit. In Western Kansas, the average was about 55 pounds of seed per acre, and in Central Kansas, the average was close to 85. So there was definitely a difference there. In Central Kansas, more humid environment, growers were going higher. They were going with about 85 pounds of seed per acre. Western Kansas, a drier environment, they were going with about 50 to 55 on average. And again, the wheat crop is very plastic, right? It can respond a lot to environmental conditions. So out west, they go with a lower seeding rate. If the conditions are right, if we have enough moisture and temperature in the fall, the crop is going to tiller out, and we might not see any yield loss from going with a lower rate. But at the same time, what they're trying to avoid is just too much growth, right? They don't have the water to maintain that excessive growth, and so they don't want too many seed rates out there. They kind of let the environment tell the plant what to do. So.
Yeah, and so to apply this to Michigan, our conditions would be more similar to your eastern part of your state, and we tend to plant higher populations. You know, the lowest that will go usually is in that 1 to 1.2 million seeds per acre, and then the later on in the season we get, you know, we bump that rate higher, getting up to 2 million seeds per acre, even 2.2 if we're planting really late, like around the 1st of November or into the middle of November. So the really dry conditions, it makes sense. You know, you want to put less plants out there so that you're only putting out enough plants that you have an amount of water to sustain. So yeah, so that makes sense. Next question is regarding to your discussion about sulfur. And the question is, what is the best way to apply sulfur?
Yeah, that's a good question there. So if we think of the plant and when it's taking up sulfur, that's what we want to know, right? When is that plant going to need it? It's very similar to nitrogen. So the sulfur uptake curve of wheat is very similar in terms of timing to that of nitrogen, right? So there's a little bit that is uptake before winter dormancy, but the bulk of it is really going to be uptake in between that break of winter dormancy and beginning of stem elongation through heading. In that time, the crop is probably going to be about, by heading time, it's probably going to be about 75 to 80% done taking up sulfur. So we want to make sure that it's available at that point in time, right? The crop needs to be able to access that sulfur together with the nitrogen. So if we look back in timing, that's when we need it available. Now, if we look at source, if you're applying elemental sulfur, that's going to take a long time to break down, right? So it's not going to be available in that same season. So if you're applying elemental sulfur, you need to think of a longer term management strategy because it's going to take time for that sulfur to be available. But if you're applying ammonium thiosulfate, urea ammonium sulfate, or any of those other sources, either dry or liquid, it's going to be available right away. So you can plan it together with the nitrogen. To be more efficiently, if you're using liquid, I'll just plan on ATS at spring green up, just together with your nitrogen there. So it's not going to be limiting to the crop.
Yeah, and we're finding similar results here too. In the sandier soils, the lighter ground, lower organic matter soils are the ones that we're seeing the better response to the sulfur, or the higher response in terms of yield response to the sulfur. So I inadvertently skipped over one here. So let me ask you another question. The pounds of nitrogen, is this available or applied? And then do you count for nitrogen from the soybeans?
Yeah, so that depends on what part of the project that we were on, which project that I showed that we were talking about, right? If you're looking at the grower data, that's that's pounds of nitrogen applied. Okay, we did not sample those fields to know how much was available, and not all growers sampled, so we cannot get that information. Now, for our projects, we always go with a fixed rate regardless of the location. Well, it depends on the project, but many projects will go with a fixed rate regardless of the location. So in the end, depending on how much nitrogen was in the soil, we end up with a pretty nice range of nitrogen available to the plant. So we always try to work with nitrogen available to the plant. Many times we even go as far as always having a zero nitrogen check. And in that zero nitrogen check, if we sample that plant in the end, like at maturity, and get its biomass and get how much nitrogen concentration you have, then you have the true amount of nitrogen available from the soil in that condition, because that's how much a zero nitrogen check was able to uptake, right? So that's accounting for how much came from the organic matter, how much was in the soil before, rainfall, and all those things. So many times we do that as well. So we're trying to always work with available nitrogen, regardless of those conditions. Was there a second part of the question, Dennis?
Well, it just said, do you count for nitrogen from the soybeans? So that would be, what is available from the previous crop?
Yeah, so we do have adjustments for a previous crop, but there's quite a bit of soybean research going on here that's kind of showing that up to 40, 45, 50 bushel per acre soybean, it's breaking even, how much nitrogen it produces and how much it takes up. And beyond that, if you have high yielding soybeans, it's actually scavenging quite a bit of nitrogen, so it's actually taking up some of the nitrogen from the soil as well. So we don't consider credits from the soybean because of that. There's still research trying to figure out how much it actually leaves back, if any. But if we do have a cover crop or a clover or something like a cover crop that would release nitrogen, that will be accounted for. We haven't worked much in those conditions. So most of our adjustments is the other way around. If we have a corn crop before or a sorghum crop planted before, and we know that residue is going to tie up a lot of the nitrogen, then we bump our rates up to account for that, right? So it's really, we have gone more in the other way of, instead of the nitrogen credits, more like, okay, considering how much is going to be tied up on the residue. And again, most of that is because the conditions that we are working with are mostly either after soy, after wheat, or after sorghum in a long-term fallow rotation. So.
Yeah, good. The next question is kind of more of just a comment. Said, thank you. That is very good, or is a very good study on sulfur response. So that was more just a comment saying thank you. So.
Oh, thank you. Appreciate the comment. Yeah.
Yeah. Okay. So next question, and I got about 3 left here. What was the organic matter level where no response to the added, or where there was no response to the added sulfur?
So we range it, right? We had this trial conducted for 3 years in several locations per year. So usually, if we had more than about 2% organic matter, we didn't see much of a response. Of course, that depended on yielding conditions. If you have a very high yield crop, 2% might not still be enough. But you know, usually those sites where we saw the response, they had 1.5 or less percent. In some of the commercial fields that we're seeing here, talking to growers that are seeing a huge response, they have even less than that, right? Maybe less than 1% organic matter, and they are definitely seeing quite a bit of response from the sulfur applied. So in our data, if we had more or less more than about 2%, we are not seeing much of a response.
Yeah, we're seeing a fairly similar response to sulfur here in Michigan as well.
Great.
Okay.
Yeah. And that, I mean, it's important to remember that we might see some early season deficiency because that sulfur coming from the organic matter, it needs moisture and it needs heat to be able to start being released to the plants. Sometimes we might see some early season, like an early spring deficiency that might go out later once conditions are better for the mineralization of the organic matter. So.
Great. Next question. In the humid areas of Kansas, do you see any interactions with seed-placed phosphorus and soil test phosphorus? And if so, is there a plateau? And maybe how high is that plateau?
Yeah, that's a good one. And honestly, I have not done that exercise of looking, you know, what's the plateau of phosphorus where we see response. But what I can say is that we did have a study to partially answer that question where we were purposely trying to find soils with high testing B. And because wheat is so responsive to in-furrow right? It's probably the most responsive crop that we have out there in terms of tillering more and yield gain as well. We were going in those high testing phosphorus sites and applying either with or without 100 units of mass. So that has phosphorus on it as well, sulfur and nitrogen. So we can't really just figure whether it was from the phosphorus or not. But we were still seeing, you know, even in high testing phosphorus sites, we're still seeing about a 5 to 6 bushel per acre gain from that in-furrow phos. But again, it was not phos per se, right? We had a little bit more nitrogen putting up there that might very well just account for that. In general, if we have more than 20, 25 ppm of malic 3 phosphorus, our recommendations don't call for in-furrow phos. These soils that we were studying, they were all above 35 to 40. But again, I can't say that it was because of the phos, right? Because we were also applying, there was nitrogen and there was sulfur and zinc in that mix of mass. So,
yeah, and we were seeing similar. We're getting some response to phosphorus in the fall as starter, whether it's placed in the furrow with the seed or just broadcast incorporated. Even on some soils that are in the upper end of that maintenance range, or even in towards the bottom of the high side of things, we still were seeing a yield response in the application of that starter phosphorus was economically feasible. So
that's it's nice to see that you guys are finding some similar results there, Dennis. And you know, one comment that I always make when we're talking about in-furrow phosphorus, especially, is that there are a few situations where in-furrow phosphorus is like money on the bank, right? And those situations will be if you're planting late. So for some reason, you have a summer crop that was harvested late, or that was too wet and you couldn't get in the field on time. If you're planting late, in-furrow phosphorus is money on the bank because it's really going to help take off that early development of the crop. If you're planting in acid soils, right, and you don't want to lime in that year, so if you're in that pH between 5.2, 5.5, you know, that's kind of like it's already going to take a toll on your yield. But you don't want to lime in that particular year for economic reasons or whatever reason. Again, in-furrow phos in those intermediate to low pH sites, money on the bank. And the third one that might not apply to Michigan as much, but is in grazing conditions, right? So if you have, which is very widely adopted here in Kansas and other parts of the well, Oklahoma and the Southern Plains as well. So if you're grazing, that in-furrow is also money on the bank. So.
Yeah. So Romulo, I do have 3 more questions in the chat right now. If anybody does have more questions, please type them in. So we'll go to the first one here. Have you done anything with variable rate nitrogen?
Yeah, so within my own program, we have not, but there is a precision ag program. Well, for quite some time, there was a precision ag program at K-State. For the last 2 years, we haven't had one, but we're picking up that again. So they were doing, they were developing a model that was slightly different from the one developed by Oklahoma State. So at Oklahoma State, there was a lot of work using NDVI, right? The green seeker, sometime in the spring there to predict the yield potential, and then adjust for that based on a nitrogen-rich strip. Here in Kansas, they were using a similar concept of having the yield potential predicted by the green seeker at different growth stages, and then adjusting nitrogen rates based on different parts of the field based on its NDVI. So most of the work that I have been familiar with is using that concept of NDVI or the green seeker measurements during the season. There's quite a bit of that being done. I mean, just using satellite data as well, and the within field variability for NDVI, sometime in that fix 3 to fix 5 time frame, and then you pick up those differences and adjust nitrogen rate based on that. Some of the results that I've seen from Oklahoma and here from Kansas as well seem to improve profitability in about 90% of the times by doing that, either by reducing the nitrogen rates overall or by putting more where more is needed. So overall, I think it's very promising. There are some concerns there, right? Because not all that is reflected in the NDVI is necessarily nitrogen deficiency. So there is that confounding factor. But overall, looking at several years of research done, that seems like 85 to 90% of the time the producers were getting more money, either by applying more or reducing where it's needed. So.
Yeah, and nitrogen is so dynamic in the soil, and a lot of factors influence availability and uptake and movement and whatnot. It's hard to give a clear cut, this is exactly how you need to manage a soil, because you go to the next field, it's going to be a little bit different. So yeah, we've done a little bit of work on that as well, but we don't have any final conclusions as of yet.
We're about in the same boat then.
Yeah. So next question, do you have any test plots regarding the different fertilizer responses to broadcast seeding versus planting through the drill? And I'm thinking this is probably your starter that we're talking about here.
So I think broadcast seeding, I guess what they have in mind is probably like with an airplane or with, just broadcast the seed and incorporate it. So we've seen, some growers have done that successfully in Southeast Kansas. So Southeast part of the state, they can have very high yielding conditions. Probably that potential that we were talking about, 75, don't apply for those guys. They probably have a higher potential. And some growers have done that, and very successful. They have a broadcast seed in the field and incorporated that and had pretty good yields. I haven't done any research with that. I would assume you probably need a higher seeding rate, right? So you're actually going to be able to compensate for the lack of uniformity there. But I don't have any research trying to confirm or not whether that's feasible.
Yeah, so I'll just follow up on that question. We kind of wrapped up our precision planting research here this last summer with harvest. And so we've got our data out on that. And I've been reporting at winter meetings what we found on our precision planting research. But one of the things that study did was it prompted some of this discussion. 2020 was a really good fall harvest season. And so farmers got their crops harvested in Michigan more timely than they have in a long time. And it seemed like a really welcome fall season to have, because the previous 2 years in particular, they couldn't buy 2 or 3 dry days in a row to get soybeans harvested. And so when you're late harvesting soybeans, you're late planting wheat. And so the question became, if we can broadcast seed on the ground and incorporate it with some of these like high-speed tillage tools they're really pretty good at controlling the depth of tillage, we can seed acres much faster. If we have a much narrower window to get our wheat planted, if we can broadcast it, incorporate it, we can do a lot more acres in a day compared to drilling. So we have established a research trial this fall on, I think, 5 different farms, where we are looking at broadcast incorporating seed with, I think we've got 4 different broadcast incorporation tools, but we're also comparing that to, you know, the John Deere air cart, the Case IH Coulter cart, no-till drill, and a few others. So we don't have any data on that yet, but it is coming. We are looking at that.
I'm looking forward to seeing the results from that, because I get those questions every time that I have a talk in Southeast Kansas. That seems to be the only part of the state that are more interested in that, probably because they have much more rainfall as well, getting into some of the concerns that you mentioned. So.
Yeah. Next question, what is your weed control on plots?
Yeah, so our line of thought there is just to make sure that they are not limiting, right? So we typically go with a pre-plant and a spring application as well, right? Many times we might use finesse depending on the crop rotation there. So our goal is just to make sure that it's not limiting, and it really ranges, depends on the region, you know. If these trials are in growers' fields, the weed control is going to be whatever the grower is doing in that field. If we have control over that in a research station or some of our trials that are in research station from K-State, we just try to make sure that they are not limiting at all. And so whatever we need to do in those terms, that's what we do to make sure that we have a clean harvest. Sorry, I didn't have a more specific answer, but it really depends on the trials that we were working with.
Yep, no worries. And the last is maybe more of a comment rather than a question. This is from John. We've been broadcast seeding wheat since the 1970s with great success. Never will go back to drilling. And so I'm hoping to find that you're right. You know, one of the things that we found as a big benefit with a precision planter was how accurate the depth control was compared to a drill. And we attributed some of the yield benefit from the precision planter to accuracy on depth control. Well, when you're broadcast incorporating, you are basically mixing the upper maybe 1.5 or 2 inches of soil, and seed is going to be kind of mixed throughout that, so you're not controlling that depth. So I'm glad to hear you're having good luck with it. I hope if that's what we can find as well, then yeah, that might be a practice we'll start advocating for.